All right, so today we're going to finish up section 4. We're going to be still factoring trinomials, but this time the number in front of x squared, the a value, isn't going to be a 1. It's going to be a number other than 1. So these are a little bit more challenging. And the two methods that I'm going to teach you how to use for factoring these trinomials is either to guess and test or to factor by grouping. Now, the factor by grouping is going to take a little bit longer. However, it works every time. But some of you, when the numbers are small, it might be easier to guess and test. But when they get larger, you might have to do a bunch of FOIL problems until you finally find the ones that work. So I don't care what method you use to factor. There's all kinds of tricks out there. So if you wanted to use one of the factoring tricks, you can do that. Some teachers give them silly names like slip and slide, or where you make them into fractions and then you reduce the fraction. Whatever method you want to use is fine with me. But again, I'm going to teach you officially the guess and test and the factor by grouping today. So what you're going to be presented with are all your trinomials. They're going to be in this standard form, ax squared plus bx plus c, where the number in front of x squared isn't going to be a 1 today. So we're actually going to have to look for factors of our first term and our last term. That combination is going to give us the middle term. So here is our first example. And I'm going to first just start out by showing you guess and test. So if you're going to guess and test, what we're going to do is we're going to think of all the factors or ways to multiply to get the first term, and then all the ways to multiply to get the last term. So if we're going to guess and test, we could automatically, our answers are going to be binomials. So to multiply to get to the 3x squared, I know I have to multiply 3x times 1x. Those are the only ways I can get there. Now, for my last term, I'm either going to put a 1 here and a 2 here, or I could set it up as 2 and 1. Now, notice both of my signs are positive in my original problem. So this tells me they're both going to be positive, positive. So when you go to do the guess and test, now at this point, you have to FOIL this to find the one that works. Now, the problem's going to occur is if these numbers are really large. And then you're going to have to do a bunch of FOIL problems until you find it. Now, some of you are really good and you're going to be able to find it and make it work. Essentially, all you're doing is outer and inner to see what you get to the middle. So if I FOIL this, I can already see that this one is going to be out. So let me go ahead and erase that one, and I'm going to FOIL the original one I wrote. So if I FOIL this, first, 3x squared, outside plus 2x, inside plus 1x, and last plus 2. Notice it FOILs back to my original. So the binomials that I found here are correct. That's the guess and test method. If that works for you, you can do that. Yes? This one, let me see if I can write it in another color. This one and this 2 come from the factors of 2. So you have to decide the 2 ways to multiply. I could have either put it in as 1 times 2 or 2 times 1. So this is where if you put the 2 here, it wouldn't FOIL back. So the placement of the factors of 2 are going to be important. And that's where you have to FOIL it. That's the guess and test. Question?
So you have to keep going, let's say you just do it wrong, you would just have to try it again, moving them around?
Yes. Okay, that's your guess and test method. I'm going to show you grouping where you're not going to have to guess and test. Yes?
What you're saying is that when you have bigger numbers, it's better to group
Yeah.
because it's less things.
Yes. Because let's say we had 24x squared plus whatever it is, plus even if it's just an 8 here. So think of all the multiples of 20, or the factors of 24. You would have to test 1 times 24, 2 times 12, 3 times 8, 4 times 6, and then over here, you'd have to match it up with the 1 times 8 and the 2 times 4 to see whatever would make that middle. So sometimes the grouping might be faster, okay? And there's even faster tricks that do it. Now, when you see how much work's going to be involved in grouping, you're going to be like, I really don't want to do all that. So you need to just find what method's going to work. The grouping method always works. It's not that bad. So here's the same problem using factor by grouping. So 3x squared, I'm just rewriting the first problem. So for the factor by grouping method, what I'm going to be doing is turning my trinomial into a 4-term polynomial that I can group. So what I'm going to do to get that 4 terms, I'm going to multiply the beginning and the end. 3 times 2 is 6. So I'm looking for factors of 6 that will give me 7. So I would list 1 times 6 and 2 times 3. And then I can see when I add those factors, the 1 plus 6 gives me the 7. So now what I'm going to do is I'm going to take my trinomial, I'm going to rewrite the first term. I'm now going to replace the middle term with these 2 factors. But I add the x's to them. So 1x plus 6x. And then rewrite the last term. Now I have 4 terms, and this is what we learned on the day 1 of the factoring chapter. I make groups. Now, it doesn't matter if I would have put the 6x first and the 1x second, okay? It's going to still simplify to the same thing. All right, so now I need to find a greatest common factor between the red group, which is going to be x. So then 3x plus 1. And now I find a GCF of the green group, which is 2. So then 2, and then divide. Remember, when you do the factor by grouping, what's in the parentheses after you divide has to be the same. So now essentially that's your GCF. So you write that once, and then you take the 2 numbers that you just multiplied or divided by. And there's the same thing we got as when we guess and tested. Good? All right. Yes?
Is there going to be a time where you say you have to use the guessing, or it says that you have to?
No. You can choose whatever method you want.
Okay.
Yeah. I don't care what factoring method you use. And again, your teacher might have shown you other ways. So whatever factoring method you want, that's okay with me. We're going to factor throughout the school year. So you need to find something that's going to work. I know when you probably took this in Algebra 1, it was probably 1 chapter or even a couple lessons, and then you moved on. So for those of you whose Algebra 1 course got you into rational equations and rational expressions, where you had to factor the numerator and the denominator and then cancel things out, you would have saw factoring more. But some Algebra 1, courses may not have gone that in depth. So, but factoring for us, we are going to do it all year long. So you need to find a method that's going to work for you and be really good at it. All right, let's try the next one. I'm going to do both methods. I'm going to do guess and test, and then I'm going to also do grouping. So again, these numbers are small because 2 only has one way to make it. It's 1 times 2. So again, my first setup, I'll put the 2x here, and I put an x here. And now I've got to decide for my factors of 3, do I put the 1 here and the 3 here, or vice versa? So this one's actually wrong. So I'm going to show you why it's wrong. So when I go to FOIL this, so when you do guess and test, you're foiling it. So if I do first, I already know for sure my first and last are going to work. So when I do that, notice the first and the last worked, but what you need to test is the outer and the inner. So when I do inner, or let me do the word FOIL. So I'll do outer first. So this would give me 6x. And when I do the inside, I get 1x. And then when I added that, notice I got a 7. What was I trying to get? 5. So this tells me that I put the 1 and the 3 in the wrong spot. And now I got to go back and do it again. So, but some of you guys are going to be really good. And the guess and test is going to work for you, and you're going to know right away, oh, wait a minute, I can't set it up like that. I need to put the 3 here and the 1 here. And now, we already know first is going to work and last is going to work. We're now just testing the outside and the inside. So again, inside gives me 3x and the outside gives me 2x. When I add them, I got the 5x. So that's my correct factored binomials. Now, same problem, factor by grouping. So 2x squared plus 5x plus 3. Again, the process is to multiply the beginning and the end. I'm looking for factors of 6 that give me 5. So I can see that's going to be 2 times 3, because 2 plus 3 is 5. So again, rewrite the first term. Replace the middle with the 2 numbers you just found. Now it doesn't matter. You would think that you would want to write 2x here first. I can also factor it the same way and put the 3x there. It doesn't matter. I'm still going to factor it correctly. So I'll just put 2x and 3x, and then again, write the last term. So now again, you make your groups. Red, green, just so I can refer to things in color. So my GCF of my red group is going to be 2x. Going to divide it and get x plus 1. The GCF of green is going to be 3. Divide it. Again, your goal is to make these two the same. Yes? The 6 was multiplying the first number times the last number. And those are the factors I'm looking for that will give me the middle when I add them. So I found the factors of 6 are going to be 2 times 3, because 2 plus 3 gives me the middle. So I'm looking for the 2 numbers that multiply to give me the end product. Does that make sense? All right, so now that I have these two the same, write it once, and then put these two together. It's the same answer I got when I guessed and tested up here. And again, the order doesn't matter if you write the x plus 1 first or the 2x plus 3 first. Yes. Essentially what we're doing here, when we multiply the beginning and the end, really what we're getting is 6x squared. So we're really looking for the factors of 6x squared, which is going to be a 2x times a 3x. So that's why that's what I put here in the middle. So whatever variable squared is there, that's what you're going to put and when you replace it in the middle. Does that make sense? All right, let's try another one. Again, this factoring stuff takes practice. And I know we had a year in between when you guys took geometry. So again, we're practicing. We're trying to get back into this here. All right, so again, we can guess and test. So again, I'm looking for the factors of 3. That'll be my first, so of 3x squared. So I know 3x times x is going to give me the 3x, which would be my first. And then I'm looking for the factors of the last term, which is going to be 5 and 1. Now, I don't know if I'm putting 1 here and 5 here or vice versa. So again, this is where I would FOIL to see which one works. Now, the other thing too is you have to watch the signs. Remember, just like in last night's homework, when the last number is positive, so when your end number is positive, the signs are the same. And the signs that both binomials will have is going to be the sign of the middle. So this is positive and this is negative, so both of the signs need to be negative. So now again with the guess and test, we're going to check the outer and the inner. So the outside gives me negative 15x. Inside gives me negative 1x. Notice when I add those, it's too big. So I put them in the wrong spot. So now I got to go back and switch the 1 and the 5. So make this a 5 now and make this a 1. And now when I FOIL it, this gives me now, let me erase this. So now I would get 5x and negative 3x. And that gives me the negative 8. So those are my correct binomials. The factor by grouping, 3x squared minus 8x plus 5. We're going to multiply factors of 15 that give me negative 8, and that'll be negative 3 times negative 5. So again, you're going to rewrite the ends, and what we're replacing is the middle with these two numbers. And again, these two numbers get x's with it, because really it's the factors of 15x squared. So we're going to rewrite 3x squared. We're taking out the negative 8x and putting in negative 3x and negative 5x. Rewrite the end number, and now make your groups. Now, again, it won't matter. If I would have put the negative 5 here, it still would have factored to the same thing. So, GCF again of the red group will be 3x. So 3x, and then I'm left with x minus 1. GCF of green. Now remember, we want what's in this parenthesis to be the same. If I pull out a positive 5, my signs are going to be off. So my GCF here is actually going to be negative 5. And then I get x minus 5. I'm sorry, negative 5 times x minus 1. Now these are the same. So I write this thing once. It's my GCF. And then put these two together. And notice it's the same thing that I got up here when I guess and tested. Yes?
How do you know not to put the 3 and the 5 and the 5 is 3?
It doesn't matter. Let me do it that way. So she just asked, what if I would have factored by grouping? So rewrite this. And what if I put this here and this here? Is that your question?
Yeah.
Okay, watch what happens. I'm going to get the same answer. You may think that it's better to put the two 3's together and the two 5's, but really, technically, it's not going to matter. So watch. So if I make this a red group and this a green group, my GCF of red this time is only going to be an x. So when I factor out the x, I'm left with 3x minus 5. And then on the other one, my GCF is going to be a negative 1 because I want my signs to be the same. And now that'll flip the sign on the 3x and on the 5, and now these two look the same. And then now I get x minus 1, these two together, and then these two are the same. So, and notice it's the same answer as when I did it the other way. Okay, so it doesn't matter the order you put those factors in there. Okay, you're going to get the same answer. Let's try this one. So again, guess and test. These are still small numbers. So it's, it's reasonable to be guessing and testing here. Because the factors of 2 are just going to be 2 times 1, and the factors of 7 are 1 times 7. So really, you don't have to do a whole bunch of FOIL problems when the numbers are little like this. So now I have to decide, is my 1 go here and my 7 here? Again, positive at the end, so my signs are the same. So they're both going to be negative because that's my sign in the middle. So again, do inside and get negative 1x, outside negative 14x. When I group them, I did get the negative 15 I was looking for. So I guessed correctly right away. Now, same problem, factor by grouping. 2x squared minus 15x plus 7. This time I'm going to multiply the ends and get 14. So I'm looking for the factors of 14 that give me negative 15. And that'll be negative 1 times negative 14. Because when I add those, I get the middle. So again, rewrite the first term. Rewrite the end, but then replace the middle with these two numbers. Group, group. And now, GCFs. GCF of red is x. GCF of green, again, remember you want the signs to be appropriate. If I pull out only a 7, my signs are off. So I'm going to pull out a -7 so everything matches up. So now I get 2x. Oops, I needed a 2 here on the red. So then I get 2x minus 1. Again, the parentheses look the same. So now I write 2x minus 1 and then the x minus 7. Same thing I got when I did it by guess and test. So I forgot to write the 2 right in here because when I divided 2x squared right here by x, 2x was left. Yes. This question was, what if we would have put it in the group like this, 2x squared, and put the 14x first? It's not going to matter. Red group. And let me do green group. So here my GCF would have been 2x. And then I would have been left with x minus 7. And then the GCF of green group over here would have been a -1. And then -1, x minus 7. Put these together. And then the x minus 7 that you've doubled. So in the end, it ends up being the same. Does that make sense? So again, it doesn't matter where you put your factors. It's still going to end up being the same. All right, let's try. So again, still little ones here. So again, guessing and testing is reasonable. Factors of 5. To make factors of 5x squared is just going to be 5x times x. That gives me my first. And now I'm looking for factors of 1. And that's just 1 times 1. But 1 has to be positive, 1 has to be negative. Because I need different signs here. So now I just have to hope that when I put them in here, I put the plus sign and the minus sign in the right spot. If not, I just do another FOIL problem. Make sense? So here, inside gives me -1x. Outside gives me positive 5x. When I add them, it worked. I guessed right. Now, if you factored it by grouping, 5x squared plus 4x minus 1, the original problem. Again, you're going to multiply beginning and end. Looking for factors of -5 that give me positive 4. So -1 times positive 5. Because when I add -1 plus 5, I get the middle. So again, rewrite the first term. Replace the middle. And again, it doesn't matter if I put -1 first or positive 5. So let's say I put -1 first. And then the positive 4. And then the last term. So now red group. Green group. Now, when I go to do this, my GCF of red is going to be x, and I'm left with 5x minus 1. GCF of the green group, I put the wrong factor here. This should be a 5. This should be a 5 here. Okay, so now GCF of the green group, notice it can't be simplified. My GCF is a 1. So I divide the green by 1. So plus 1. And again, I'm left with 5x minus 1. So again, these are the same. So now 5x minus 1. And then you put these two together. Same answer I got when I guess and test. Next one, again, my last number is negative, so my signs are different. So again, let's write the 3x, so 3x and x. Factors of 5. So now I have to figure out, is the 1 going to go first or the 5? So if I put 5 and 1, and again, my signs need to be different. All right, so this is where I'm going to try it, and I need to confirm by foiling it. So negative 5x, positive 3x, and notice when I combine them, I did get the middle. So I guessed correctly. So let's try the grouping. So again, let me rewrite the problem. Again, you're going to multiply beginning and end. Two numbers that'll multiply to give me negative 15, but who add same numbers to give me negative 2. So we can see that's going to be 3 and 5, and the 5 is going to be negative. So again, rewrite the first term. Replace this middle with these two numbers. Again, you would think you need to put the 3x first, but it'll still work if we put the negative 5 there. It doesn't matter. So again, make your groups. GCF of red is 3x. GCF of green is negative 5. Because again, you want the parentheses to be the same. So same, same, write it down, and then put these two together. And I got the same answer as when I guessed and tested. Now, the next example, notice this one, the number's a little bit bigger. So if I do guess and test, and I'm not going to do guess and test because it's going to take me too long on this one, but if I did, this would have been 1 times 8 and 2 times 4 that I would have to test. And then for the 21, 1 times 21 and 3 times 7. So it's not that many, but I got to figure out, does it go with this one? Does it go with this one? Or is it this one that goes with this and this? So I may end up having to do maybe 4 different FOIL problems. But again, it'd probably take me about the same time as the grouping, but I'm going to do grouping. Now, when I multiply this though, I am getting a kind of big number here. So 21 times 8, and I get 168. So I need to figure out what times what gives me 168, and it's negative, but when I add those same two numbers, gives me a negative 2. Now, when I'm trying to find a small middle term, that tells me my numbers need to be close. They have to be 2 apart. Okay, so those factors of 168 are going to be 12 times 14, and 14 is going to be negative. So I'm going to go ahead and put it into my group. Rewrite the first term. I'm replacing negative 2 with the 12x and the negative 14x. And then I'm rewriting 21. Again, if you put the 14 first, it doesn't matter. So now let's go ahead and make your groups red and green. And now factor the GCF out of red. And my GCF of red is going to be 4x. So 4x, and then you're left with 2x plus 3. And then GCF of green, again, we want the thing to look the same, so I'm going to pull out a negative 7 GCF. So then I'm left with 2x plus 3. Again, your goal was to make these the same. It is. Write it once. And then the two things that you just divided by. And you're done. Again, FOIL it. Make sure it does go back. The next one, again, I'm going to still do factor by grouping. You could do this one, guess and test. You would have to test out 1 times 9 and 3 times 3 with 1 times 8 and 2 times 4 until you found the one that works. But let me just go ahead and do the grouping. So 9 times 8 is 72. Factors is 72 that are going to give me a negative 18. And that's going to be negative 6 times negative 12. Because when I add them, they'll give me 18. So again, rewrite the first term, replace the middle with these two numbers. Rewrite the last term. Make your groups. Red group, green group. GCF of red is going to be 3y. 3y minus 2. GCF of blue, again, your goal is to make it the same. If I pull out a positive 4, my signs are going to be off. So I'm going to pull out a negative 4. And then I'm left with 3y minus 2. So the answer here is going to be 3y minus 2, what you got in the parentheses, and then these two together. 3y minus 4. One more, and then we'll do the perfect square trinomials. Again, this one's not so bad because the factors of the last number is 1. So it's like -1. So here, factors of 30, we're either going to have to test 1 and 30, 2 and 15, 3 and 10, or 5 and 6. What makes this a little bit easier is the middle number. It had to be 1. So this tells me that my factors have to be right next to each other. So if I did guess and test, I could just put in here 5a, 6a, and then the factors of this are going to be 1 and 1. So 1m and 1m, the signs just have to be different. And that's where you could double check which one gets the plus, which gets the minus. Now, if you did factor by grouping, you're looking for the factors of -30. Rewrite this. Factors of -30 that give you 1. So again, it's going to be the 6 and the 5, and the 5 is negative. So again, rewrite first term. Replace the middle with a 6 a.m. and a -5 a.m. And then rewrite the last term. So this is this, and it replaced that. So now, make your groups. So my GCF of the first group is going to be 6a. And I'm left with 5a plus m. My GCF of green is going to be -m. And I'm left with 5a plus m. Again, your goal was to make these the same. Write it once, and then put these two together. And you're done. So now let's try the perfect square trinomials. Now, it would really help you if you can memorize these patterns. It just makes things easier, especially when you go to take the SAT. So just remember that when the two ends are perfect squares, then chances are the answer is just going to be the square root of these, and then you square the binomial. The sign that goes in between is the sign that's in the middle. Now, I'll show you a trick that you can confirm that it does give you the middle term. So let's try some of these. Otherwise, we can still do the factor by grouping on these also. Here, the pattern is, see how it's times 2? It's the x times y times 2. The problem with the factor by grouping is the numbers could get really large. So if you didn't recognize that 16 and 25 were perfect squares, then you would have to do 16 times 25, get that number, find the factors of that number that give you -40. But if you're good at recognizing perfect squares, what we're going to do is you would square root this and square root this. The square root of 16 is 4. The square root of 25 is 5. So I'm going to square root them. I'm going to multiply them. And then I take that product and times it by 2. If after I do those two multiplied and then times 2, if it gives me the middle number, then I know it's a perfect square trinomial. And all I have to do is square root this, gives me a 4p. Square root this, it gives me a 5. And then the sign in the middle goes here, and it's the binomial squared. If this, when you multiplied here, didn't give you 40, then you can't do this trick. You have to do it by grouping. Yes?
Why is it 20 times 2?
Because if you look at the pattern, so it's the trick that you can use for this. Now, I'm going to do this one with grouping and doing it with the trick. So again, these are perfect squares. So I'm going to try to square root them. So the square root of 9 is 3. The square root of 4 is 2. And then I'm going to multiply that and then times that by 2. It's always times 2 after you get the product. If it gives you the middle, you know this is a perfect square trinomial. So again, square root the first one, gives you 3mn. Square root this one, and you get a 2. Put the sign that's in the middle and write it as a binomial squared. Now, if you didn't recognize that, we can still do this by grouping. It still works. So let's say you didn't realize that, so you'll multiply beginning and the end. We're looking for factors of 36 that give me 12. And you can see that that is going to be 6 times 6, because 6 plus 6 gives you 12. As soon as you see it's going to be the same factor, that should be a clue that it's a perfect square trinomial. And the two factors will be the same. Does that make sense? But if you didn't realize it and you're going to keep going, rewrite the first term. Replace the middle with the two factors you just found. So 6mn, 6mn. Rewrite the end. And now make your groups. A group here and a group here. So my GCF of red is going to be 3mn. So 3mn. And then you're left with 3mn plus 2. And over here, the green group, this is going to be a GCF of 2. And then you're left with 3mn plus 2. Again, your goal was to make these the same. They are the same. Write it once. And then put these two together. And notice it's exactly the same thing. You can either write it like that or write it as 3mn plus 2 squared. Either way. Yes? Yes. There. Okay, so either way, if you're good at recognizing perfect squares, it definitely makes the process easier. You just square root the ends. But you have to confirm that it gives you the middle term. Like, let's say the problem was, let's just say it's 9m squared plus 13m plus 4. If you do the trick and you square root these, you're going to get 3 times 2 times 2, which is 12, but you were trying to make 13. So in this case, you'd have to do the factor by grouping or the guess and test, because the factors of 36 that give you 13 are going to be 9 and 4. Does that make sense? So sometimes it's not a perfect square trinomial, even though the ends are perfect squares. So you must do this little trick to make sure it does give you the middle. So that is the end of factoring of those trinomials. You do have homework. It's page 43. It is number 23 through 39 odd. So again, you need to be really good at factoring. If you want to learn any kind of tricks, I can show you some of them. But the factor by grouping and the guess and test never fail. That's usually what's taught in a textbook. And that's it for this lesson.